Okay, guys, so we are going to talk about, let me go back a couple of pages, inverses on graphs and tables and what a relation is. And you're going to be able to, from this lesson, you're going to be able to find out what an inverse is, how to find an inverse from of a function from a relation or a graph, what a one-to-one function is, and when can we find the inverse of a function. Okay, so an inverse just means to switch the x and y values of a function. That's the operational definition. And a one-to-one function is a function that has only one y value for every x value. And let me give you an example. So let's say I gave you this relation, and I'm going to just put it in chart form for you. And f of x is the same as y. 1, 2, 3, and I go 2, 4, 5. So first, you have to check if it's a function. And the definition of a function is, and I'll go ahead and write that, for every x, there is only one unique y value. Okay, so every input has only one output. So here, the number 1 only goes to number 2. The number 2 only goes to number 4. The number 3 only goes to number 5. So that's a function. Now, but the definition said that a one-to-one function has only one y value for every x value. So now I'm going to go backwards. Does the number 2 go to only one value? Yes, it goes to number 1. Does number 4 goes to only one value? Yes, it goes to number 2. And does number 5 only go to one value? Yes, it goes to number 3. So that is also a one-to-one function as well. So here, a relation, it just means a mapping from a x value to a y value, which a mapping to an input and an output. Now, relations don't have to necessarily be functions. Let me give you an example. Okay, so here I go 2, 2, 5, 6, and 3, 2, 1, 0. All right, so this is definitely a relation. Okay, the inputs go to an output. However, this is not a function because the 2 is repeating itself and it's going to two different numbers. It's going to a 3 and a 2. So this is not a function because the 2 is repeating on the x side and is going to two different values on the y side. Now, if the number 2 had went to the number 2 again on the y side, then this would have been a function because it's the same exact point. But the 2 is going to a unique or a different y value on this side. So it's not a function, but it is a relation. And since this is not a function, it is also not a one-to-one function as well. Okay? And it can't be one-to-one because it's not a function. All right? So these are some of the keywords that you need to know. And let me give you an example for an inverse. So the example for an inverse would be, if I gave you a table, I said x, y, 1, 2, the inverse of that would be to just switch the x and the y. So the inverse function would be 2, 1. Okay? So it's just that simple. Just switch the values of the x and the y. Alrighty, so let's look at this from a graphical standpoint. We did the tables in class already, so now let's look at this graph. So this is a graph of a function, negative 2x plus 2, and it says, is this a one-to-one function and why? So the definition of a one-to-one means every x has only one, first it has to be a function, so every x has only one y, and then the one-to-one means that every y has only one unique x that it goes to. So since this is a graph, it would kind of take us some time to write all these points out and check. But there's a little test you can do to check it out. Now, we're going to do what is called the vertical line test to see if this is a function first. And here's what the vertical line test means. If I draw a line right here, does it touch that line once? Does the orange line touch the blue line once or twice? So I'm going to take this orange line, and I'm going to, if it'll let me, hold on. I might have to do it. Yeah, there we go. I'm going to take this orange line, if it'll be nice to me, and I'm going to drag it. It's not going to be nice to me. I want to drag it. I might have to go a different route. I want to take this line and I want to drag it. Oh, it's not going to let me do it. But I want to drag it across this blue line, and that's what the vertical line test is. And I'm just going to have to draw it. I'm going to drag it across this blue line right here and make sure it only intersects this blue line one time every time I drag it. So if I drag it here, it touches it once, we good. If I drag it here, it touches the blue line once, we good. If I drag it here, it touches the blue line once, we're fine. And I can keep putting these orange lines on here, and as long as it touches this blue line only once where I put it at, then we're good. That's called a vertical line test. So we know this is a function, so we're good on that. We know it's a function. So now we need to test, is it a one-to-one function? And hold on. So to test graphically if this is a one-to-one function, then I'm going to do what is called the horizontal line test. Because the definition of a one-to-one function, it means every y has only one unique x value. So I'm going to do what is called a horizontal line test. And because this thing is not going to be nice to me and let me drag it, I'm going to have to just keep drawing lines. So if I do the horizontal line test, it touches the graph only once there. If I do another horizontal line test, it touches it only once there. It touches it only once there. So, see, it only intersects that graph once. And if I draw other horizontal line tests, then I would see that it'll work too. So here we're going to say, yes, this is a one-to-one function. And that's because it passes the horizontal line test, or I'm going to go a little deeper, because each y value has only one x value. It has only one x value as the output. Okay, so we're good with that. So can we find the inverse? And we're going to say yes. And we're going to find the inverse, yes, and that is because the function is a one-to-one function. So we're good to go. And it says, then if you can find the inverse, what would the inverse be? So in this case, we're going to need to take a couple of points off of this graph so that we can find the inverse. So first thing I want to do, and I'm going to put this, I'm just going to write some points first. So, and I'm going to put this answer down here so I have room. So in order to find the inverse of this function, I need to first get some points off of this graph. And here's the catch. If it doesn't give you any points, then you just need to find some points that are on the line. If it doesn't give you any points, then find the points that are on the line. But we're lucky in this case because it gave us 2 points. And then I'm just going to take a third point. So I want to say x and f of x for the original function. So I'm going to go ahead and take a negative value too. I'm going to do negative 1 gives me out 4. And then at 0, it gives me 2. And at 1, it gives me 0. All right. So there I have a table for that graph. And now the definition of finding the inverse means to switch the x and the y value. So I'm going to say when I do the inverse, and this is the symbol for inverse, then that means I switch the x and the y value. So f of inverse of that would be 4, negative 1, 2, 0, and 0, 1. And this is the inverse symbol. So here I'm going to go up here and I'm going to graph the inverse. So 4 and negative 1. So 4, 1, 2, 3, 4, and negative 1. And then 2 and 0. So 2, oops, I'm doing it. 2 and 0. And then 0 and 1, which is right here. Okay, and here I'm going to connect those dots. And this is the inverse function. And if you want to be even more accurate, then you go and get you some more points and just switch the x and y. So this is the inverse function of that function right there. And you're done. All right, you're done. So let me see if there's another for us to practice with. No, that's it. So it's your turn to try the next one. And remember, if the function fails the one-to-one test, then you cannot find its inverse, okay? So make sure your function passes the one-to-one test. And if it doesn't, then you just say that. It's not. I can't find the inverse because the function is not one-to-one. And you go from there. All right, see you guys later.